Hi there. So in this section, we are going to look at solving quadratic equations by factoring. And we'll go ahead and start here in example 1 with a quadratic equation. And actually, even before that, I'm going to come down below and just sort of talk briefly about the difference between a linear versus quadratic. With a linear functions, the degree of all linear functions is always equal to 1. So remember, your degree is that highest degree of exponent, the highest degree of on x, exponent on x. So with that x here, this is like x to the first power, versus a quadratic down below, you have a, b, and c are just numbers, but you notice how it goes x squared, x, and the c just being a number. That highest exponent there is 2. That indicates that you're talking about a quadratic equation. And if you recall from before, a linear equation was always a straight line. We'll talk about quadratics, and I'll actually graph out example 1 here for you just to give you a visual of what a quadratic looks like whenever you graph it, okay? So here in example 1, it says that water droplets are sprayed from the ground, from a ground level fountain, and the height in feet of a droplet can be modeled by the polynomial function here, h of x represents time in seconds, and h is your height, all right? And so they want us to complete this table here. And so we're going to look at the first 5 seconds of a water droplet, okay? So I want to know what's its height 1 second after it's, been shot up out of the ground, okay? So what that means then is I'd go to my function here, and everywhere I see an x, I'm going to plug in 1. So I have 1 squared plus 80 times 1. You could put that in your calculator. That should land you at 64 feet. All right, then you would do the same thing with 2 seconds. So it'd be negative 16. Everywhere you see an x, plug in 2. And that should put you at 96 feet. All right, you continue on down after 3 seconds, it should also be at 96 feet. 4 seconds, you should be at 64 feet. And at 5 seconds, you should find that lands you at 0 feet. And over here on the box on the left, I said, well, how long does it take the water droplet to hit the ground? Well, remember that you're plugging this into a height function, so this is the height. We can see then after 5 seconds, it has hit the ground because it has 0 height. So 5 seconds would be our answer here. Now I'm going to take this data here, and I'm going to, like I said, just give you a rough picture of what's going on here. So along the x-axis, we're measuring time in seconds. And we looked at the first 5 seconds. So 1, 2, 3, 4, 5 seconds. And then on the y-axis, we're measuring height in feet. So height measured in feet. Okay, and I'm just going to count by 20s here. So 20, 40, 60, 80, 100. Okay, give us a rough sketch here. So now let me plot some points. We know that it started at the ground, so at time 0 it was at the ground. 1 second later it was at 64 feet. At 2 seconds it was at 96 feet. 3 seconds it was also at 96 feet. 4 seconds it was back down to 64. And then at 5 seconds back down to the ground. So the trajectory of this water droplet looks something like this. As we move further in the class, we're going to talk a little bit more about this. We'll be able to find out, well, when does the droplet hit its maximum height, okay? And what is that maximum height? So that'll be something to come later on in this course, okay? All right, so with that said, and then my other key point in this was just graphing out a quadratic here for you, showing you that a quadratic is no longer a straight line, and it's got that curve to it. The quadratics are always parabolas. In this case, we'd say this parabola faces downward. Again, we will talk more about graphing those later on in this course. All right, so let's scoot on down to example 2. In example 2, it wants to know whether these equations are linear or quadratic. So you're just looking at your degree. So hopefully you agree here in part A that I've got degree 2, so this has to be quadratic. I'm just going to abbreviate. And in letter B here, I'm raised to the first power, so this one has to be linear. I'll let you try C and check yourself by the solution key. Let's move on down to the zero product property, because this is what's going to allow us to solve quadratic functions by utilizing this property. And what the property says is that if you have two factors multiplied together, so a times b, if they equal 0, then either a equals 0 or b equals 0, or they both equal 0. And so what's going to happen is that when we're going to factor our quadratics, and we're going to use this property to set every factor that has a variable, so every factor that has a letter with it gets set equal to 0 and solve. Right, and you'll see what that means here and just down below. So down below in example 3, I'm going to go ahead and do all three of all this whole example with you. It says solve each equation. So in part A here, you've got 18x equals 0. So that's very straightforward to solve for x. I'm just going to divide both sides by 18. And so x equals 0. That's your one and only solution there. Okay. Now coming over to B, this one's already in factored form. This is what I meant by up at the top. It says set each factor with a letter, a variable, equal to 0. 9 is a factor, but it does not have a letter with it. So I don't set 9 equal to 0. I only set x plus 6 equal to 0 and solve for x. Because remember, when you solve equations, you're trying to solve for a letter. If I try to set 9 equal to 0, there's nothing to solve for. Okay, so you only set factors with letters equal to 0. So here I set x plus 6 equal to 0, solve for x, pull that 6 over, so x equals -6. Final answer. Okay. Down below in letter C. So I've got two factors here. The first factor is m minus 7. The second factor is m. So I'm going to set both of those equal to 0 and solve for m. So, the one over on the right's already solved. M equals 0. So that's one of my solutions. The other one to solve for m, so I'll add 7 to both sides. Both of my factors had letters with them, so both of the factors needed to be set equal to 0 and solve for m in both cases. Letter D here, just solve for x. Hopefully you agree. Subtract 8 from both sides, so x equals -8. One and only solution. Okay. All right, let's flip it on over then to the next page. All right, so solving equations by factoring. You want to make sure that your quadratic's in descending order and set equal to 0. If it's not set equal to 0, then you need to get it equal to 0. You're going to factor, and then you're going to set each factor with a variable, so each factor with a letter equal to 0 and solve for solve. Those are going to be your solutions. Every solution that you find, just like solving any other equation, can be plugged back into the original to check yourself. Okay. So I'm going to do all three of the examples in example 4. So this one is example 4 part A. It's in descending order. It's already set equal to 0. So I am ready to factor. Only way to multiply to give me x squared. X and x. Most common way to multiply to give you 10. I agree with 2 times 5. Outside and inside. So outside I got 5x. Inside I've got 2x. My goal is to get a 7x here. I can do that. I'd have to make them both positive, so plus plus, and then do the final double check at the end. 2 times 5, that gives me 10. These are both of my factors, so they both have letters. So x plus 2 equal to 0, x plus 5 equal to 0, and solve for x. So I'll show a little bit of work here. As you do more of these, you probably can start eyeballing your solution, and that would be a-okay with me. That you have -2 and -5 as your final answer. Okay. All right, let's move over to letter B. In letter B, this is a two-term polynomial, so I'm ready to factor that, but that's not like your guess and check. Remember, this is where you ask yourself the three questions. Can you take the square root of the first term? Yep. Can I take the square root of 100? Yes. Is there a minus sign in between? Yes. Then we are ready to factor this difference of squares. Square root of h squared, square root of 100. Signs on these, plus and a minus. Both of them have letters with them, so they both get equal to 0. So h plus 10 equal to 0, h minus 10 equal to 0, and solve for h. So pull that 10 over. One of my answers is -10. Pull that 10 over. The other answer is +10. And those are my two solutions. Okay. And then let's do letter C over here. All right, so this one is not equal to 0. Okay, so I need to get it equal to 0. You notice in the previous two, we were already equal to 0. So in letter C, I'm not equal to 0, so I need to pull that 20 over first. So I'm crossing the equals mark. I'm going to do the opposite. So I'm going to have 3x squared minus 7x minus 20 equal to 0. Now I'm ready to go to my guess and check. It's three terms, right? So the only way to multiply to give you 3x squared, 3x times x. Most common way to multiply to give you 20, 4 times 5, let's put the 4 in the back and 5 in the front. So on the outside I've got 12x, inside I've got 5x. My goal this time is a negative 7x. I can get that, but I'd have to make what negative? We agree it's got to be the 12, right? 12's got to be negative. So where am I getting 12? When I do 3 times 4, that's where I'm getting my 12. So the minus sign goes in front of where you're getting it. Do the last double check at the end. 5 times negative 4, that gives me my negative 20. Both of these factors have letters with them, so they both get equal to 0. So 3x plus 5 equal to 0. X minus 4 equal to 0. I'll do this one first. I'll pull that 4 over. So x equals 4. That's one of my solutions. Over here, I'm going to pull that 5 over. 3x equals negative 5, and then divide by 3. So negative 5/3 is my other answer. So negative 5/3 and positive 4, those are my two solutions. All right, so let's come on down to example 5, and it says solve each polynomial by factoring. So it's just basically more practice with the kinds that we just got finished doing. So what I'd like to do is I'm going to do letter A here with you. So this is, looking at this factoring, does it have a common factor? I'm already equal to 0, and don't let the fact that the equal to 0 is over here on the left, that can easily just be written like that, okay, and then ignore it over there, okay? Do these two terms have something in common? And hopefully you agree they do. They both have a 16 in common, and let's go ahead and pull out a negative 16, and they both also have an x in common. So now write what I have left over. So if I pulled out a negative 16, then that's going to leave me with a positive 1x. Negative 16 times what gives you a positive 80? It have to be a negative 5, and I already have my x. Now both of these factors, negative 16x is a factor and x minus 5 is a factor. They both have letters with them, so they both get set equal to 0. And solve for x. So over here we just divide by negative 16. 0 divided by anything, still 0. So there's one of your answers. Over here, add the 5. So x equals a positive 5. And there's my other answer. Okay. All right. In letter B, hopefully you recognize I need to get it equal to 0 first. The first thing you do there is pull that 6 over. I'll let you try that one on your own. You can go ahead and pause it now if you like. Okay. Let's go over to C. C, if you'll notice here, I've got some distributing to do, and I'm already not equal to 0. So I'm going to distribute. So p times p squared, p times 5, 5p equals 14. And then, like I said, I got to get it equal to 0, so I'm going to pull that 14 over. So subtract 14 from both sides. So I'll have p squared plus 5p minus 14 equal to 0. Now I should be able to factor. The only way to multiply to give you p squared, p and p. Most common way to multiply to give you 14, 2 times 7. So think about your outside and inside. You got 7p and 2p. Trying to get a positive 5p, so you'll have to make your 2 negative, so minus positive. They are both have letters with them, so they both get set equal to 0 and solve for p. So if I set this one equal to 0, I should get a positive 2, and this one should give me a negative 7. Those would be my two answers. Okay. Letter D is very similar. I will just note here, you notice how it's not already equal to 0. So what you're going to have to do on this one is you're going to have to FOIL it first, pull that 10 over, and then factor. Okay. And then let's come on down to letter E. Okay. In letter E, I'm in descending order. I pull out my common factor, and so all three of these terms have an A in common, and write what I have left over. They don't have any numbers in common, so that'd be 24a squared plus 10a minus 25 equal to 0. All right, so now let's come down and let's factor, I guess, and check. Most common way to multiply to give you 24, I'd probably say 4 times 6. Let's try that. 4a times 6a. Most common way to multiply to give you 25, 5 times 5. Let's do outside and inside. So 4 times 5, that's giving me 20a. Inside, 5 times 6, that's giving me 30a. My goal is a 10a. I can get that. I'd need to make my 20 negative. 30 minus 20, that would give me a positive 10. All right, where am I getting 20? That's 4 times 5, so that's right here. 4 times 5 goes in front of where you're getting it. 5 times 6 is 30. I need it positive, so I'm putting the positive sign there. Then I set, notice how I've got 3 factors here. I need to set all 3 of these factors equal to 0. So I am setting, they all have letters with it, so A equals 0. 4a plus 5 equals 0, and 6a minus 5 equals 0. And then I solve for a in all 3 cases. Well, the first one's already solved. When you do this one, you're going to pull that 5 over and then divide, so you should get, what, a negative 5/4. Kind of run out of room. I showed all my work on my solution key. And then from here, I'm going to pull that 5 over and then divide by 6, so you should get a positive 5/6. Those are your 3 answers there. You'll see as you move forward here, if you're, well, I won't go that far yet. Okay. All right. So then let's come on down to example 6, and let's try this one together. So in example 6, it says that a company's average cost per item per C in dollars and in number of items are produced in a day can be estimated by this equation. So C represents the cost and N represents the number of items that are produced. Part A wants you to estimate your average cost when 5 items are produced in a day. So all that needs to happen in part A here is that 5 items, so I'm going to plug everywhere I see an N, I'm going to plug in 5. And then that should give you, multiplying, put that on your calculator, you should land at $660. Okay. I really wanted to focus on part B with you. Part B says find the number of items produced in a day that results in the average cost per item being $840. So here's our formula. So the negative 6n squared plus 162n equals a cost now of $840. So first thing I'm going to do is I'm going to pull that 840 over, because I got to get it equal to 0. So I have a negative 6n squared. All right, so now what do all 3 of those terms have in common? Hopefully, you know, this might be a little bit of guess and check in your calculator, but negatives or 6 will go into all 3 of those. And because we want to keep that first term positive, let's pull out a negative 6. And that would be n squared minus 162 divided by 6 is going to be 27. 840 divided by 6, that's going to give you a 140. All right, so now let's come on down. Let's try to do our guess and check now. The only way to multiply to give you n squared. N times n. Now think about, I know 140 is a big number, so just think about 14. What's the most common way to multiply to give you 14? I hopefully agree with that. It's 2 times 7. Well, so then let's think of this then as 20 times 7, right? Because 20 times 7, that would give me 140, okay? And 20 and 7 can give me 27, right? So let's do 20 times 7. So outside I've got 7n, inside I've got 20n. I want a negative 27n. I can get that. I'd have to make them both negative, so minus, minus, and then it checks on the end because a negative 20 times a negative 7 will give me a positive 140. Now here, excuse me, I set all of my factors that have letters with it equal to 0. Negative 6 does not have a letter with it, so it does not get set equal to 0. So I only set n minus 20 equal to 0 and n minus 7 equal to 0. I'll pull that 20 over, so n equals a positive 20. That's one of my answers. Pull that 7 over, so n equals a positive 7. So when they produce 7 items or 20 items, you get a daily cost. The company's cost would be $840. Okay. All right, that finishes this section. Thanks a lot. Bye.